Hi everyone, welcome to the third lesson of KS Coding. If you have not watched the second video yet, please go back and watch the second video. And if you have any question or concern, please leave a comment in Google Classroom, and we'll answer you as soon as possible, okay? And today what we're gonna learn is logic. Logic exercises that will be fun, and we'll give you an introduction to MakeKit, okay? So first, pause the video and try to do this problem, okay? Give yourself a minute. Don't Google this. Do not. It's pretty easy to find. So please come back after you have put your thought into this. All right, welcome back. Hopefully you thought of an answer. And guess what? We'll talk about the answer later in the lesson. So hopefully you had some sort of process to reason out what the answer might be. And that is what logic is. So logic, well, by definition, is disciplines like mathematics, linguistics, law, physics, pretty much everything, okay? Even though we listed a few items here, it's actually everything. In everyday life, what we do is we use logic. And a fancy way to say that is it's science of reasoning. And it helps us to reason out whether something is true or not. And that's what logic is. And we talk about how logic is a science of reasoning, and there are two main types of reasonings. And because this is not, like math course or science course, we're not going to go deep into it. But I wanted to give you some introduction of some reasonings. Hopefully, everyone has heard this phrase, deductive reasoning. You have learned this in math. In science, you might be thinking, hey, why are we talking about this deductive reasoning, even though this is computer class? Well, the reason is logic is not only important in math and science, it's also important in computer science, also programming, and like I said before, everything, okay? So deductive reasoning is, well, let's read the definition. A proposition or conclusion is made from set of premises or hypotheses. So when we say hypothesis, it's a statement, or there are statements that we can determine whether it's true or not. So let's read an example. Number one, all men are mortal. So that means eventually everyone dies, right? Number two, Socrates is a Greek philosopher and mathematician and scientist is a man. So from these two premises or hypotheses, what can we conclude? What is a proposition we can make? Therefore, Socrates is mortal. So this reasoning might be too obvious, right? But this sort of thing is called deductive reasoning. And that's what we do everyday life. Okay? It's not just for fancy math or science, it's everyday life thinking. Okay. The stronger deductive reasoning we become a better problem solver. So two exercises, I'll give you time to read this, take a minute, and try to come up with conclusion you can make from given two premises in example number one and example number two. All right, welcome back. So conclusion from number one is something like Ramon is eligible to play sports because, number one and two. So example number one is pretty obvious one, but example number two may not be too obvious because maybe some people have said Grace was tardy at least 3 times, but guess what? This is not valid. It's not a valid conclusion. And let's think about why. Because if you have 3 tardies, then you must go to detention. And the fact that Grace is in detention, does that really mean that she has at least 3 tardies? Not necessarily, right? Because she might have done something other wrong things. That's why she might be in detention. So from this information, we cannot conclude that Grace was tardy at least 3 times. So when we're doing deductive reasonings, you have to really think about what might be possible. Is that the only possible way or not? Now, another type of reasoning is inductive reasoning. And inductive reasoning can be found most commonly in science and also in IQ tests. So if you want to do this sort of questions, you can just Google IQ tests or practice tests. So you can do some questions like this. But anyway, what inductive is this? So in inductive reasoning, we find general pattern or rule by using bunch of cases or observations, in this case, particular cases. And that's what science does, right? Scientists experiment many times, not just once, many times, and they try to find pattern, and they generalize, and they make theories, and they do more experiment, right? And it becomes law, it becomes like a strong theory, and that's what inductive reasoning is. And downside of that is there's no 100% certainty, because why? Inductive reasoning can only give you conclusion based on those observations. That means if we observe something different, right? Something that defies previous theory, then we might have to modify our theories. That's why science is always evolving and developing and improving. All right. So let's look at this problem figure. So based on this four figures, right? Based on this pattern, what might be the fifth one? Pause the video for a few seconds and answer. Okay, hopefully some people, maybe a lot of people have said number 4. Hey, even if you said number 4, right? I mean, most likely it's not number 4 based on pattern, right? The pattern is first one flips, second one flips, third one flips. Maybe most likely fourth one will flip, depending on this. I mean, if this pattern continues, but does that guarantee it? No. So most likely the answer is 4, but not 100%. Now, another inductive reasoning is this: pause the video and do it yourself. Okay, welcome back. I will not give you the answer here. I will actually post the answer later in the PowerPoint so that people can try it. But for now, I'm going to move on, okay? It's annoying, right? If I don't give you the answer right away. All right, so this one, we have done this already. Hopefully, let's talk about this since we have talked about it already. If you don't have the answer, pause the video again and try this again. So here, there might be maybe different answers, but most obvious one for me is 14. Now, why do I think it's 14? Is because, well, if you look at corresponding or opposite, not corresponding, opposite pies, right? You add them up, what do we get? 24. 7, its opposite pi is 17, you get 24. Here, 11 plus opposite one, 13, 24. So there's a pattern where every time you add the two opposing pies, you get 24. So why did I say 14 then? I have no idea why I said 14. so if you have 4, right, most likely this number will be 20. I have no idea I said 14. So I meant to say 20, okay? So 20 plus 4 is 24. So most likely it's 20, okay? Now, you might have say something different answer. And is that wrong? No, it doesn't mean that. But what you have to do is you have to be able to prove it or show your case. In this case, I show that, hey, in this pattern, we find a general pattern that has what? 24 as a sum in the opposing pies. All right, let's move on. So logic is very useful, and the uses are everywhere. Okay, there's no point of going through this slides because, like I said, it's used in everywhere. Okay, there are only 4 topics, 4 things I wrote here, but they're actually everywhere. But in science or computer, it's usually called algorithm. And the reason why logic is important in the computer is because if you remember, programming or coding is what? Giving instruction to a computer. Computers right nowadays are so good that they can pretty much do, well, not everything, of course not, but they can do so much things that people couldn't even imagine in the back, maybe in 50 years ago, okay? But the limitation is us, okay? Even if the computer can do everything, if our coding is not correct, then there's no point of this coding. Now, even if you know all the coding syntax and all the programming languages, but if your logic is wrong, then that program is useless. So that's why even if people who cannot code, they might be able to code better than me or us or programmers, as long as they have strong logic. So throughout the course, I don't want you to just focus on how to program, how to drag and whatnot, but focus on what? Building up your logical thinking, because that is the foundation of coding. Okay. All right, moving on. So some of you might have seen this question already. So pause the video. Oh, let's read the question together at least. Can you get all 4 cross
the river safely. So we have four things, right? We have person, carrots, goat, maybe sheep, I don't know, wolf. So there's some constraints. The constraint, what that means is a restriction. There's a limit. So constraints are this: only men and at most one other item are allowed in the boat. Okay. Only the man is able to operate the boat. So that means what? You cannot put wolf and shit together because why? They can't drive. I do not leave the goat alone with carrots, and do not leave wolf unsupervised with the goat because you know what happens. And two are allowed on the boat. Okay, using this, let's try to come up with solution. So when you do this solution, right, don't just think. Okay, write it out. Write out step by step. Because why? When we write computer programming, computers cannot read our thoughts just yet, at least for now. So what that means is, in order to give instruction to the computer, you need to be able to clearly write step by step what to do in what time. Okay, pause the video and do it. I'm going to show you the answer. Okay, welcome back. So here's the answer. Now, I'm not going to go through this, but hopefully everyone has something along this line. Now, moving on. Another question. So this is also a logical question. Try this. I'm not going to talk about the answer today, but maybe tomorrow in the meeting or when we meet in the Zoom. But it's worth going over this. Write it out. Try to think about what's not possible, what's possible. Making mistakes is part of building up logical thinking. Okay?
So last week we talked about how to make app on your smartphone or your tablet. So if you don't have it yet, please bring them. Pause the video, of course, and come back after you are ready. All right, welcome back. So open up your Make app, and today let's go to learning. Learning and learning. And like I said before, in this 14-week program, we'll be mainly focusing on learn the basics of Make. This too we'll deal with next time. But for today, we'll go to IMD ICT Fusion Maker. All right. So today, what we want to do is we want to get familiarized with block coding and Arduino. Okay. And starting next week, we'll start with our first project, create a traffic light. Yay. So for today, let's go to block coding. All right, block coding and getting close to Arduino. All right, next. What do we need today? Well, what do we need? We need these three things: Arduino, Uno, board, and the cable, and OTG. OTG is simply means adapter that connects USB to your computer or smartphone or your tablet. Okay. Step-by-step coding number 1. Try coding on the Arduino control board, LED number 13. So even if you don't have Arduino Make it yet, you don't need it right now. So let's just go on. All right. Description number 1, built-in LED can be controlled by pin number 13. Okay. So even if you don't have the kit, that's fine. So let's continue and see what it says. All right, so we have our block coding here. I'm going to zoom in so you can see. All right, so what do we see here? We have two things here, right? One is when Arduino is turned on, and we have forever, okay? So remember, our goal is to turn on LED pin number 13, right? So if you look at our left side, right, we have control LED. So obviously we want to go to LED. You can click on it to get there, but today you don't have to because why? We don't have much things here, right? So here LED, we have two options. So let's use the first one. Just click and drag, okay? Click and drag, and just put it here. And what does it say? LED pin number 13, turn on or off. But we want to turn it on, right? So the question is, where do we put this? Well, if you put this, what does that mean? Well, let's read through this, right? When Arduino is turned on, right? So when the board is turned on, what it's saying is run the following code. So when it's on, it's going to go down in order. So when it first goes down, it says LED pin number 13 turned on. And then once it's done, what happens? The end, right? So it's turned on and it's finished. All right. But what if we put this in the other side? Forever. Now let's run it. All right. So forever. So when it's turned on, what does it do? It goes down and it turns on, and then it goes down. And then do you see this arrow? What does it mean? Repeat. Come back and then repeat the whole thing. Turn it on and then repeat. But does it really matter? We turn it on, that is already turned on. So in this case, there's no difference, right? So you might be asking, hey, when do we use this or that? Well, it really depends on context, okay? So for now, let's go on, right? Next. Now I will blink the built-in 13 LED, one gap, what it was supposed to say was every 1 second, okay? So we're trying to make a code that blinks LED light that is in pin number 13, blink every 1 second. So now, how about this? Pause the video. Wait, hold on. Pause the video here and try to build that on your own using the control and LED options you have. Come back once you're done, okay? All right, so there might be different answers you have, but let's start, okay? So it doesn't really matter where we start first. I'm gonna start with when it's turned on, okay? All right, so when it's turned on, I mean, when the Arduino is turned on, you want to turn on LED light, right? And then if you want to blink, right, you want to turn it off, right? But it says every 1 second. So what does that mean? You need some sort of waiting time. So I think it's better to have waiting time in between, right? Yeah. So what's wrong with this? There are a couple of things that are wrong, but let's talk about one obvious thing, right? So when it's turned on, it will execute or run the following code in order, right? So when it's turned on or it's turned on, number one, it will first turn on the LED light. Perfect. After that, it waits 1 second. Perfect. And it turns off, right? So it's like blink, and then what happens? Done. Does it turn back on? No, because why? Like I said before, when Arduino is turned on, it only runs once, okay? But what do we want? We want to run this continuously, right? So what does that mean? We don't want to use when Arduino is turned on, we want to use forever. So let's click and drag, right? How easy is that? Pretty easy, right? So let's zoom in a little bit more. So let's talk about what this is going to happen. The question is this what we want? Maybe, maybe not. We'll see. So forever, when Arduino is on, the first thing we're going to do is turn on LED number 13. Perfect. Wait 1 second. Perfect. And after that, it turns off, right? And then it doesn't finish. We have a repetition sign. So it goes back up, right? And then repeats from the beginning. So it was off. So now it's back on. Wait 1 second, turns back off, and repeat. Now, is this what we want? Not quite, because why? If you look at this, there's a waiting period between on and off, but is there a waiting period after off, between off and on? No, so what this is gonna do is this, on, off, on, off, on. So it does blink, but it doesn't blink as what we want. So what do we need to do here? Think about it, pause the video, come back once you're done. All right, so a simple solution is adding a wait second after turn on or turn off. So this will do what we want. On, 1 second, off, 1 second, on, 1 second, off, 1 second. And this will continue forever as long as Arduino is turned on, okay? So as you can see, even though we have same block of code, right? Here, it only blinks once, and here it will blink continuously. So this is why not only when coding, right? It's not only important to know what functions we have, what options we have, but we need to be aware of context and what do we want, okay? Because it matters, okay? Let's move on. By the way, if you want to repeat the video, please always feel free to repeat, because why? That's the beauty of having video lessons, right? All right, submission, submit your photo if you want to, okay? I'm not gonna do that. So exit for now. All right, so next time for your homework, I want you to look through creating traffic light, okay? You don't have to build it. If you want to, you can start building it, but I want you to get familiar with what we're trying to do here, okay? So get familiarized with the names and the parts, and next time we're gonna go through together to build traffic light.